So I have this triangle here, right? And I labeled the angles, okay? I'm going to cut the angles off. And I'm going to put them together. I'm putting all the orange parts together. What do you notice about those three angles together when you put them together like that? It makes 180 because that's a line down here. It's supposed to be if you put them exactly together, which is tough to do. But anyway, that's supposed to make a line right there. That means those three angles together add up to equal 180. Well, those three angles were the angles in that triangle. And what that's supposed to tell you is that the angles in a triangle add up to 180. And I think maybe you already know that. But I'm just reminding you one way that you can see that those angles would add up to 180. And what we're going to do first, this first part right here, is I'm going to do a proof, okay? Just to show you where it comes from. Now, keep in mind, what I told you about proofs is that I'm not going to give you a proof and say, okay, write it and do it. But I might give you a proof where here's all the statements filled in and I want you to come up with the reasons that these are true. Okay? Or I will give you parts of it and you have to come up with different parts. So I'm going to go through the proof with you and show you how to do it, although I'm not asking you to come up with it on your own. Okay? So when you do a proof, the very first part of a proof is always to write down the given. And in this case, the only given part that we know is that EC is parallel to AB. Alright, well if EC and AB are parallel, are there any angles that are congruent? So looking at that triangle and those lines that are parallel, are there any that are congruent? Is 4 congruent to anything?
Like 4 and 5 or 4?
You have to think about parallel lines and think about alternate interior, alternate exterior, vertical. Think about all those kinds of angles. What angle would angle 4 be congruent to? 1. Because basically I'm thinking about this as the transversal. And I'm thinking about this as the parallel lines. Does that make sense? So angle 4 and angle 1 would be congruent. Okay, well tell me about angle 5. What would angle 5 be congruent to if this is the transversal? 2. Do you agree? What kind of angles are angle 4 and angle 1? Alternate interior. What about angle 5 and angle 2? Alternate interior. Okay, so here's what I know so far. I know that angle 4 is congruent to angle 1, and I know angle 5 is congruent to angle 2. And the reason for both of those is alternate interior angles. Because those two lines are parallel, it makes these alternate interior angles, and alternate interior angles are congruent. Okay, besides all that information that we just came up with, is there anything else we know specifically about these three angles? 4, 3, and 5. Is there anything you know about angles 4, angle 3, and angle 5? They are linear. So if they're linear, what's the measures of all the angles?
180.
So all three of those added together are 180 because they are linear angles. Well, if angle 4 is congruent to angle 1, could I put angle 1 where the 4 is? If angle 5 is congruent to angle 2, couldn't I put angle 2 where angle 5 is? Okay, let's see what happens if I do that. Now, why can I do what I just did? What's it called that makes me be able to put in a 1 for the 4 and a 2 for the 5? Starts with the S.
Substitution.
Notice what I was trying to prove was that measure of angle 1, angle 2, and angle 3 were 180 because those are the angles in a triangle. Is that what I ended up with? Yeah. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. And those are the three angles in a triangle. So that proof is just to show you that, yes, it's true, the three angles in a triangle do equal 180. Okay? And we know that that's going to equal 180. So if I'm going to find these missing angles in these triangles below, and I want to find this one over here, I'm going to add these and subtract from 180 to get that one. So 65 plus 57, and then subtract from 180. And you get what?
What is that?
58. And then number 2. So this angle here at the top is 40. What's this angle down here?
50.
90, because of the box. So 90 plus 40, subtract from 180, and you do get 50. All right. And then number 3, 85 plus 50. And then subtract that from 180, and you should get 45. All right, this theorem is kind of a strange theorem. First thing I want you to know is that these are not in the right places. The printer just messed up on them. So this is supposed to be a 4, this is supposed to be 3, this is supposed to be 1, and this is supposed to be 2. They just don't, those little numbers were just not in the right places. So, okay. So first of all, I'm going to prove the theorem to you, and then I'm going to explain it a little bit more. Basically, what we want to happen is we want measure of angle 1 at angle 2 to equal measure of angle 4. So these two angles in the triangle are going to equal that one that's way far out there. And that's what exterior angle theorem says, is that if you have two angles in a triangle and you know them, then you can add them together and get the one on the complete other side, which is the exterior angle. Okay? So, very first thing you're going to do is write this statement, and that's the given. So we know that we have a triangle ABC, and we know that there's an exterior angle, number 4. And we know that that is given to us, because it's what they tell us. Okay? Looking at the angle 1, the angle 2, angle 3, and angle 4, is there anything I know about any of those angles?
They all equal 180.
Which ones equal 180?
1, 3, and 2.
Okay, 1, 2, and 3 equal 180. Why is that?
Because all triangles equal 180.
All the angles in the triangle equal 180. So my reason is that we have triangle ABC. We know that the angles in a triangle equal 180. And it's called triangle sum theorem. So I know that the angles all add up to 180. Okay? Anything else important I know? There's actually two other angles that add up to be 180.
Would be 2 and 4 and 3. D, A, and C.
It's two angles that equal 180.
Would it be 4 and 3?
4 and 3. Why is angle 4 and angle 3 equal to 180?
Oh, because down here is a straight line.
So 3 and 4 make a line, right? They're called linear angles. So they equal 180 also. Well, if 1, 2, and 3 equal 180, and 3 and, that's supposed to be 4, and 3 and 4 equal 180, is it true that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals measure of angle 3 plus measure of angle 4?
Yeah.
And what's our reason? Why can I do that? Why can I take this measure of angle 3 and 4 and put it up there where the 180 is?
Because it equals
And so what's the thing called that allows you to do that? It's substitution. Okay, one more thing I want to do. Think of solving the equation right there. What could you do on both sides that will help you solve the equation? Is there anything there that's on both sides? See how measure of angle 3 is on both sides? Could I subtract measure of angle 3 on both sides? You actually can, so I'm making one more step. And measure of angle 1 plus measure of angle 2 equals measure of angle 4. And my reason is subtraction. Because I'm getting rid of angle 3 on both sides. And now I've got what I was asking for. I wanted 1 and 2 to equal 4. And that's what happens with the exterior angle theorem. So on number 1 down there on the bottom, if I'm trying to find this exterior angle because it's outside the triangle, I can add the two angles that's not connected. So I can add 70 and 50 together, and that will give me that angle out there. So what is it?
120.
Now, if you don't like the way that problem is done, you could add those together and subtract from 180 to get this angle at U, which would be 60. And then if you subtract 60 from 180, it will still give you the 120. So you can do it either way. So number 2. Here's the two angles away from our exterior angle. So what are we going to do? Add them together. You get 115, and then that's the answer. Okay, number 3. There's a couple ways to do it. One way that I like to do it is I first want to get this angle beside the 120. What would that equal? 60. Because 120, or 180 minus 120 equals 60. Okay, now I have 60 and I have 50, so how can I get the question mark?
You add 60 and 50.
So I will add 60 and 50, subtract from 180. So that'd be 180 minus 110, which is 70, and then 70 is the answer. If you don't like that way, you could have said, well, this is 120, so I know these two angles up here have to add the 120. So I could do 120 minus 50 to get 70. That's another way. I think this way, the way I did it first, like it's very straightforward, but you can do it the other way also.